Hi, I'm Robert Strauss from Los Alamos, New Mexico, USA. In my project, I'm simulating the visual cortex of the brain to demonstrate the potential of neuromorphic computers for more efficient computation. Right now, your brain, running on just the power of what you had for breakfast, is doing complex visual processing, facial recognition, speech recognition, balancing you upright, and more, all at once. If your computer tried to do all of the calculations for all of those tasks, it would burn up. It's unlikely we could achieve the brain's level of efficiency with the digital hardware we use now, but with neuromorphic computers, we may be able to. There's just one catch. We don't know how to program them. So instead, what if we train them, since they're meant to work like a brain? The goal of this project was to demonstrate how neuromorphic computers could be trained for a task, in this case, teaching a system to see. But what does seeing actually mean? I decided to define it in two parts. First, understanding what an image is, a classification task. And second, being able to visualize an object from the raw input, or reconstructing a clear image. Rather than using a typical image as the input to train it, I used a silicon retina because it more closely mimics the eye, since it only outputs spike signals. A pixel fires a spike when its intensity changes, which means it takes pre-processing to reconstruct a recognizable image. I simulated the brain by solving differential equations of over 1 million neurons, and trained it by backpropagating error through not only layers, but spike signals and many iterations of those millions of driven differential equations. After many iterations of architectures to correct for problems like overfitting, my classifier model correctly identified the moving digit 95% of the time. My reconstruction model managed to reproduce stabilized still images from the moving silicon retina data, even down to very small details. And amazingly, despite only being trained with handwritten digits, it also generalized to all sorts of images. So I have demonstrated how neuromorphic computers can be trained to accomplish a task, and I have shown excellent generalization on a few tasks.